Hi dear students in grade 6. This is our mathematics exam review worksheet solution for our semester 2. Please concentrate and be ready. We are going to solve very important exercises. The topics covered in our semester 2 exam are fractions 1, in which we have studied about reducible fractions and non-reducible fractions. We've seen what are decimal fractions and how we can change some numbers into fractions, and we remember together important things about decimal numbers. The second lesson is the perpendicular bisector of a segment. If we have a segment, we've learned how to draw its perpendicular bisector using a long ruler and a set square, and it's very important to always remember the definition of the perpendicular bisector of the segment. Our next lesson is the angles. In this lesson, we've remembered together from grade 5 what is an angle, how can we draw an angle, how can we measure an angle. We use the protractor to draw and measure an angle. What are the kinds of angles? The null angle, the acute angle, the right angle, the obtuse angle, and the straight angle. After we've revised these, we started with our first lesson, which was about the adjacent angles. What are the conditions to know if two angles are adjacent? And what are the conditions to know if two angles are vertically opposite? Then we've constructed together the bisector of an angle. If we have an angle, how can we draw the bisector of an angle? And also it's very important to remember the definition of the bisector of the angle. Then we have seen if we have pair of angles or two angles, when are these two angles complementary and when are these two angles supplementary? Question number 1. In this question, we should indicate whether the following statements are true statements or false ones. Two adjacent angles are always equal. This is false. It's not necessary for two adjacent angles to be equal, but two vertically opposite angles should be equal. 2/7 is a decimal fraction. To know if a fraction is decimal or not, we look at the denominator. Because the denominator is 7, so it's not decimal and it cannot be changed into decimal, so also this statement is false. The measure of a straight angle is 180 degrees. Yes, it's true because a straight angle makes a straight line. The bisector of an angle divides it into two equal angles. This is the definition of the bisector, so this is also true. The two fractions 6/9 and 2/3 are equivalent. We can see that 6 to become 2 we divided by 3, and 9 to become 3 we divided by 3, so we divide up and down by the same number, so these two fractions are equivalent fractions. This is true. The fraction 15/16 is reducible. No, this is false. This fraction is irreducible because 15 and 16 are relatively prime, or they are successive numbers. Any fraction having a denominator and a numerator as successive numbers, it will be irreducible and not reducible. A pair of angles are said to be complementary if their sum is 180 degrees. This statement is false because the sum of two complementary angles is 90 degrees and not 180 degrees. Now, if we have 27 plus 4/10 plus 9/1000 plus 2/10,000, this writing is the expanded form of a decimal number. So is it equal to 27.492? Let's see. 27 is the whole part, so we write 27 point. Now let's start with the decimal part. In the 10th, we have 4, so we write 4. Now we should have 100th. We have no 100th, so we write 0. The 1000th is 9 and the 10,000th is 2, so this statement is false. Question number 2, we have now to talk about decimal numbers and decimal fractions. In part A, we are given decimal fractions. We should write them as decimal numbers. We have 57 over 100. Always we have here steps. What are the steps? First, we should write the numerator as it is. So we write 57. Now we should put our finger to the right of all the digits near 7. While putting our finger, we look at the denominator. How many zeros do we have in the denominator? In the denominator, we have 2 zeros. So we should move our finger to the left 2 digits. 1, 2, it is 0.57. Now 9 over 1000, so we write 9, we put our finger to the right and we move it 3 digits to the left. 1, we still have 2 zeros, we've moved it 1 0, so 0, 0, 0.009. 26 over 10, we write the numerator as it is. In the denominator, we have 1 0, so we move it to the left 1 digit, so we write 2.0. 3 over 100, we write 3, and because we have 2 zeros, we move it to the left 2 digits. 1, the other is 0, so it is 0.03. Now we have to write 107. We should move it to the left 4 digits, 4 zeros we have. 1, 2, 3, the fourth is 0 and we write 0.0107. 233 over 100, we write 233. Because we have 2 zeros in the denominator, so we should move to the left 2 digits. 1, 2, so we put point. 2015 over 1000, we write 2015. We have 3 zeros in the denominator, so we move 3 digits to the left. 1, 2, 3, it is 2.015. Now 7 over 10, we write 7. Because we have 1 0, so we move it to the left 1 digit, 0.7. Now in part B, we should write these decimal numbers as decimal fractions. Also here we have steps. Because we should write a fraction, the first thing we write is the line of a fraction. Now here we should look for the numerator and the denominator. To know the denominator, we look how many digits we have in the decimal part. We have 2 digits, then we write in the denominator 2 zeros. Now in the numerator, we write 3418. We write the number as it is without the point. So we write a line of a fraction. We have 3 digits, so we write 3 zeros in the denominator. We write the number as it is without the point. 17.7. We have 1 digit in the decimal part, so over 10, we write the number as it is without the point. Here, line of a fraction, because we have 4 digits, so we write 10,000 and we write 6103, the number as it is without the point. It's not necessary to write the 0 here because we don't take it in consideration. So now we have 3 zeros. We have 3 digits in the decimal part, so 3 zeros in the denominator, so we write the number as it is without the point. Also, we write over 1000. Because we have 3 digits, we put 3 zeros in the denominator, we write 4 over 1000, the number as it is without the point. Question number 3. We should complete the following equivalent fractions. To complete equivalent fractions, we should see if the second fraction increases or decreases. If it increases, then we multiply the first fraction. If it decreases, then we divided the first fraction. We have 4 over 9 equal how much over 45? 9 became 45. How? We multiply down, we multiply up. 9, we multiply it by 5, it becomes 45. So 4 times 5 is 20. 5 over 4 equal 35 over how much? 5 became 35. How? We multiply up, we multiply down by 7 by 7. 4 times 7 is 28. 3 over 10 equal how much over 60? Because 10 increases to 60, so we multiply by 6. Up, we multiply by 6. 3 times 6 is 18. 5 over how much equals 30 over 54? 5 became 30. How? We multiply by 6. So now we multiply by 6. What number do we multiply by 6 to give us 54? It is 9. 9 times 6 is 54. 1 over 8 equals how much over 88? 8 became 88. How? We multiply by 11. So up we multiply by 11. 1 times 11 is 11. 21 over 9 equals 7 over how much? 21 became 7. How? We divide by 3. So down we divide by 3. 9 divided by 3 is 3. 18 over 81 equals how much over 9? We divide by 9. So up we divide by 9. 18 divided by 9 is 2. 24 over 40 equals 12 over how much? 24 became 12. So we divide by 2, down we divide by 2. 40 divided by 2 is 20. Now 20 became 5. How? We divide by 4. So we divided 12 by 4. 12 divided by 4 is 3. 45 over 20 equals 9 over how much? 45 became 9. How? We divide by 5, so we divide by 5. 20 divided by 5 is 4. 77 over 99 equals how much over 9? 99 became 9, so we divide by 11, and up we divide by 11. 77 divided by 11 is 7. Question number 4, we should draw segment AB equals 4 centimeter. So this is the segment AB where AB is equal to 4 centimeter. This is AB. We draw AB using a long ruler. Now we should trace a line D, which is the perpendicular bisector of AB. To draw D, which is the perpendicular bisector of AB, using the long ruler, we should find the midpoint of AB. So we divide 4 by 2. It gives us 2 centimeter. So at 2 centimeter, we assign the midpoint of AB. This is equal to this. Now, using a set square, we put this set square on AB passing through the midpoint, and we draw a perpendicular at the midpoint. This is line D. So line D is the perpendicular bisector of AB. Now let M belongs to D. Let's take any point M belonging to the perpendicular bisector D. What can you say about M and the 2 points A and B? Because M belongs to D, which is the perpendicular bisector of AB, we can say that M is equidistant at an equal distance is equidistant from both points A and B. What do we mean by equidistant? We mean that the line MA is equal to the line MB. Now we should define the perpendicular bisector of a segment. It is a line perpendicular to the segment at its midpoint. At its midpoint. The definition of the perpendicular bisector is very important. Now in part B, we should construct an angle EFG equals to 80 centimeter. To draw an angle EFG, we should know that F is the vertex of the angle. The first line is FE and the second line is FG. So now we draw the first line, which is EF. This is EF. Using a protractor, we put the protractor at point F on line EF, and we draw the 80 degrees. This is G. Now this angle is EFG. Now we should trace FH, the bisector of EFG. Because the measure of the angle is 80 degrees, always to draw the bisector, we should divide the measure of the angle by 2. It gives us 40 degrees. We put again the protractor inside the angle, and we assign at the 40 degrees. This is the bisector, which is FH. It's very important to put these two marks because the two angles EFH and HFG will be equal. because the bisector divides the angle into two equal angles. Now, what can you say about the two angles EFH and HFG? We can see that these two angles are adjacent angles. Now we should define the bisector of an angle. The bisector of an angle is a line that divides an angle into two equal angles. Question number 5, we should reduce the following fractions first using the method of successive division. We should try to divide the fraction starting from 2. If we can divide it by 2, we divide it. If not, we go to the successive of 2, which is a 3. Here, you should use criteria of divisibility because they help you very much. So, criteria of divisibility by 2, by 3, by 4, by 5, by 6, by 9, by 10. 4 over 10, they are both divided by 2 because the ones is even. 4 divided by 2 is 2 and 10 divided by 2 is 5. 2 over 5 is an irreducible fraction. 20 over 35, we can divide the 20 by 2, but 35 cannot be divided by 2 because the ones is not even. By 3, 2 plus 0 is 2. 2 is not a multiple of 3. By 5, they are both divided by 5 because the ones is 0 and 5. 20 divided by 5 is 4. 35 divided by 5 is 7. 4 over 7 is an irreducible fraction. 9 over 21, we can't divide by 2. We can divide up and down by 3. 9 divided by 3 is 3. 21 divided by 3 is 7. 3 over 7 is an irreducible fraction. 18 over 30, we can divide both terms by 2 because the ones is even. 18 divided by 2 is 9. 30 divided by 2 is 15. Now this fraction is also reducible. We can't reduce by 2. We can reduce it by 3. 9 divided by 3 is a 3. 15 divided by 3 is 5. 3 over 5 is an irreducible fraction. 35 over 14, this fraction cannot be reduced by 2 or by 3 or by 5. It can be reduced by 7. 35 divided by 7 is 5. 14 divided by 7 is 2. 5 over 2 is an irreducible fraction. 18 over 45. 18 can be divided by 2, but 45 cannot be divided by 2. We can divide up by 3, down by 3. 18 divided by 3 is 6. 45 divided by 3 is 15. 6 over 15, we can also reduce it by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. 2 over 5 is an irreducible fraction. 40 over 30, we can reduce up and down by 2. They are both divisible by 2. 40 divided by 2 is 20. 30 divided by 2 is 15. 20 over 15, we can reduce both by 5. 20 divided by 5 is 4. 15 divided by 5 is a 3. 4 over 3 is an irreducible fraction. 24 over 80, we can divide up and down by 2. 24 divided by 2 is 12. 80 divided by 2 is 40. Also, we can reduce it by 2. 12 divided by 2 is 6. 40 divided by 2 is 20. Also, we can reduce by 2 because the ones is even. 6 divided by 2 is 3. 20 divided by 2 is 10. 3 over 10 is an irreducible fraction. Now, these fractions, we should reduce them by method of GCD. Method of GCD, we should make the prime factorization of 48, the prime factorization of 72. We choose their GCD, and after that, we divide all the fraction by the GCD. What are the prime factors of 48? It's divided by 2. It gives us 24. By 2, it gives us 12. By 2, it's 6. By 2, 3. And by 3, it's 1. So the prime factors of 48 are 2 times 2 times 2 times 2 times 3. Now the prime factors of 72. By 2, it is 36. By 2, it's 18. If we divide by 2, gives us 9, by 3 is 3, by 3 is 1. So the prime factors of 72 are 2 times 2 times 2 times 3 times 3. Now from these prime factors, the prime factors of 48 and the prime factors of 72, we choose the GCD of 48 and 72. In GCD, we choose the common, the less common. 2 4 times and 2 3 times, so we take 2 3 times. 3 1 time, 3 2 times, we take 3 1 time. Now 2 times 2 is 4, 2 times 3 is 6, it is 24. So we divide both terms of the fraction by 24. 48 divided by 24 is 2, and 72 divided by 24 is 3. 2 over 3 is irreducible. The same thing we do it for 144. We get its prime factors. If we divide by 2, it's 72. It's divided by 2, 36. By 2, it's 18. By 2, it's 9. By 3, it is 3. By 3, it's 1. So the prime factors of 144 are 2 times 2 times 2 times 2 times 3 times 3. Now the prime factors of 96. If we divide by 2, it gives us 48. Divided by 2, it gives us 24. Divided by 2, it is 12. Divided by 2 is 6. Divided by 2 is 3. Divided by 3 is 1. So the prime factors of 96 are 2 times 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 times 3. Now we should choose the GCD of 144 and 96. It's equal to, here we have 2 4 times and 2 5 times, so we take 2 4 times. 3 2 times and 3 1 time, we take 3 1 time. 2 times 2 is 4, times 2 is 8. 2 times 3 is 6, so 8 times 6 is 48. We divide up by 48 and we divide down by 48. How can we get the answer without making division? From the prime factors of 144, let's cancel the prime factors of 48. So we cancel 2 4 times, 1 2 3 4, and we cancel 1 3, so we get 3. From the prime factors of 96, let's cancel the prime factors of 48. We cancel 1 2 3 4, and we cancel a 3. 2 times 2 is 4, so 3 over 4 is an irreducible fraction. Now 120 and 216, we write 120 as prime factors. Divided by 2, it is 60. Divided by 2 is 30. Divided by 2 is 15. Divided by 3 is 5. Divided by 5 is 1. The prime factors of 120 are 2 times 2 times 2 times 3 times 5. Now the prime factors of 216. If we divide it by 2, it gives us 108. Divided by 2, it gives us 54. Divided by 2, it gives us 27. Divided by 3, it gives us 9. Divided by 3, it is 3. Divided by 3 is 1. So 216 equal 2 times 2 times 2 times 3 times 3 times 3. Now we get the GCD of 120 and 216. It's equal to, here we have 2 3 times and here we have 2 3 times, so we take 2 3 times. 3 1 time, 3 3 times, we take 3 1 time. 5 is not common, we don't take it. 2 times 2 is 4, 2 times 3 is 6, so 4 times 6 is 24. We divide up by 24 and we divide down by 24. Now from the prime factors of 120, let's cancel the prime factors of 24. 1 2 3, and we cancel 3, so we get 5. And from here, let's cancel 1 2 3 and 3. 3 times 3 is 9, so 5 over 9 is an irreducible fraction. Question number 6. Observe the figures, then answer. We are given this figure Are the two angles ABE and EBD adjacent? We should justify. To know if two angles or a pair of angles are adjacent, we have three conditions. Before we start, we should know the vertex of the first angle, the sides are BA and BE. The second angle, the vertex is B. The first side is BE and the second side is BD. Let's mark the angle inside the figure. The angle ABE is this angle, ABE. So this is angle ABE. And angle EBD, this is angle EBD, EBD. This is angle EBD. We should say, why are these two angles adjacent? We can see them, they are adjacent, but we should follow the conditions. Condition number one, they have the same vertex, which is B. So they have same vertex, which is the vertex B. Their vertex is B. The second condition, do they have a common side? We can see that in the first angles, the sides are BA and BE. In the second angle are BE and BD. So we can see that BE is a common side. So they have a common side, which is BE. The third condition, they are situated on both sides of their common side. This is the common side. We have one angle above the common side and one angle is below the common side. So they are situated at both sides of their common side. Because the three conditions are true, now we say that angle ABE and angle EBD are adjacent. They are adjacent angles. Now, in the second figure, we should see if the two angles are vertically opposite angles. Also here the vertex is O, the first side is OX, the second OY. The vertex is O, the first side is OZ, the second side is OT. Let's mark the angles XOY, so this is angle XOY. Angle ZOT, this is angle ZOT. We can see that these two angles are vertically opposites, but we have to follow the conditions here. We have for vertically opposites, we have two conditions. Condition number one, do they have the same vertex? Yes, their same vertex is O. So we write they have same vertex, which is O. The second condition, this is the first angle, XOY. How did we get ZOT? We elongated, or we continue XO to have OT, we continue YO to have OZ. So this is the second condition. Their sides are the continuation of one another. Now we can say that the two angles XOY and ZOT are vertically opposite. These are the conditions. Question number 7. We should find now the missing angles in each figure. In the first figure, we can see that we have an angle AOB. OE is the bisector of this angle. So the two angles AOE and angle EOB are equal. Because angle EOB is equal to 30 degrees, then angle AOE is equal to 30 degrees. So this angle is 30 degrees. In part B, we have a big angle, which is MOS. MOS is a straight angle. So the sum of these all angles is 180 degrees. We have here three angles. We have angle MON, we have angle NOP, and we have angle POS. All these angles are 180 degrees. So MON is 60 degrees, NOP is a missing angle, and POS is 20 degrees. So 60 plus 20 is 80 degrees plus NOP. These all the angles are equal to 180 degrees, so NOP is equal to 180 degrees minus 80 degrees. NOP is equal 100 degrees, so this angle should be 100 degrees. In part C, we can see that we have a big angle which is AOB, and this angle is right, means it's equal to 90 degrees. In this angle, we can see two angles. The first angle is AOC and the second angle is COB. These two angles are adjacent and complementary. Their sum is 90 degrees. So we can directly say angle BOC equals 90 degrees minus 50 degrees. It's equal to 40 degrees. So this angle is 40 degrees. Question number 8, we should construct the following angles. Angle AOB is equal to 80 degrees and angle BOC is equal to 40 degrees, and these two angles are adjacent. First, in the first angle, the vertex is O, first side is OA, second side is OB. In the second angle, the vertex is O, first side is OB, second side is OC. Because these two angles are adjacent, they have the same vertex O. What is their common side? BO is the common side. We should write that BO is the common side. Now we draw the first angle, which is AOB. So we draw AOB, which is equal to 80 degrees. This is using a protractor. We draw angle AOB, which is equal to 80 degrees. Now we should draw angle BOC. We know that BO is the common side. I want to draw it with another line, with another color. So BO is the common side. We put the protractor on BO at O, and we assign the 40 degrees, and we draw the second angle, which is BOC, and this angle is equal to 40 degrees. In this way, we get two adjacent angles. In part B, we should draw two vertically opposite angles. It's very easy to draw two vertically opposite angles. First of all, because EFG and HFK are vertically opposite, we know that two vertically opposite angles should be equal. Then these two angles are equal to each other. Each one is equal to 70 degrees. The first angle, the vertex is F. The sides are FE and FG. We draw angle EFG equals to 70 degrees. This is EF. Using a long ruler, we draw it with a protractor. We assign the 70 degrees, and this is angle EFG, which is 70 degrees. Now, it's very simple to continue drawing the vertically opposite angle, which is HFK. We know that F is the common vertex. It is the vertex between the two angles. It's very simple. We just elongate EF and we elongate FG. So directly we get angle HFK. We just elongate the lines of the first angle. So this angle is also equal to 70 degrees. In part C, we should draw two angles XOY and YOZ, which are complementary angles. Always to draw complementary, we know that the sum of these two angles should be 90 degrees. So we start drawing a right angle first. This is a right angle using a protractor. Inside this angle, we know that the vertex is O, so the vertex of the angle is O. We draw a line XO. Using a protractor, we put the protractor inside the right angle and we assign at XO, we assign the 25 degrees. So this is why this is XOY equals to 25 degrees, and this is YOZ. Like this, we get two complementary and adjacent angles. Question number 9, we should change the following into decimal fractions. We know that we have some fractions that are special and can be changed. They are not decimal, but we can change them into decimal fractions. The first fraction is 7 over 4. 7 over 4, we know that 4 can be changed into 100. How can we change 4 into 100? We multiply it by 25. In a fraction, whatever we do for the denominator, we also do it for the numerator. So, because we multiply 4 by 25, we should multiply 7 by 25. Now 7 times 5 is 35, 5, 3 in hand. 7 times 2 is 14 and 3 is 17. 175 over 100 is a decimal fraction because the denominator is 100. Now 33 over 50, also 50 is changed into 100. We multiply by 2, so up we multiply by 2. 33 times 2, it is 66. This is a decimal fraction. 3 over 8, 8, we know that 8 is changed into 1000. We multiply it by 125, so multiply 3 by 125. 3 times 5 is 15, 5, 1 in hand. 3 times 2 is 6, 1 is 7. 3 times 1 is 3. 375 over 1000 is a decimal fraction. 5 over 7, let's look at the denominator. The denominator is 7. 7 is never changed into 10 or 100 or 1000 or 10,000. So this fraction is unchangeable. It cannot be changed to a decimal fraction. 11 over 2, 2 is changed into 10. How do we change 2 into 10? We multiply by 5, so up we multiply by 5. 11 times 5 is 55. 55 over 10 is a decimal fraction. 7 over 25, 25 can be changed into 100. We multiply 25 by 4, so we multiply 7 by 4. 7 times 4 is 28. 28 over 100 is a decimal fraction. 17 over 200. 200 can be changed into 1000. How? We multiply by 5, so we multiply up by 5. 7 times 5 is 35, 5, 3 in hand. 1 times 5 is 5 and 3 is 8. 85 over 1000 is a decimal fraction. Now, justify why are the fractions irreducible. The first fraction 1 over 12 is irreducible because any fraction having a numerator equals to 1 is always irreducible. So here the reason because it's irreducible because the numerator is equal to 1. 14 over 5 is irreducible. Why? Because 14 and 15 are successive numbers. So the fraction is irreducible. Thank you, my dear students, and all the best in your semester 2 exams.